with the same topic of traffic data collection, but what we have discussed up to now was general. Okay, so we will not talk about any specific item of data which has to be collected. But now in this topic and the next one, we will pick a specific item of traffic data and we will see how it is collected and calculated. So we will start with the collection of spot speed data. Okay. Remember, before this we have discussed the 3 different techniques of traffic data collection, right? 3 different types of techniques. What were those? Manual, semi-automated and fully automated. Okay. So manual, you have to be on the field. Semi-automated, you can place an equipment on the field, but there's a portable equipment and you place it and then you can carry it with you when the work is done. And fully automated, then the equipment is installed on the road and you don't have to come. You install it and the data is collected and transferred. Okay. Now we will talk about doing spot speed studies. Okay. So a spot means what? This is a spot, right? Meaning what? It's is specific area. And how big is the area? It's a spot. Okay. So it's a point basically, right? It's a point. So spot speed studies meaning that you are collecting speed over a spot, point. Okay. So to collect the speed over a point or a spot, then we should have some radar or a detector or something like this. Right? Okay. But it may happen, it always happens, that we may not have a radar or a detector. Okay. Some of you are very smart. You start looking for where the government put the radar, right? You take that highway where there is already a speed radar, right? I see it in there or something. But let's say the government was not considerate about you and did not think about you while you were putting the radar. So there are more groups and less radars. Okay, then what do we do? Okay, how do we collect spot speed data? For poor people like us, they have given us a range. Okay. So if you don't have a radar, then you will do simple distance upon time, right? You will have a distance, you will record the time of the vehicle to cross a distance, and then you will do distance upon time, right? Okay. So how much distance is allowed for a spot speed study? Okay, less than 1,000 feet. Okay, so if you have taken a distance of less than 1,000 feet, it can still qualify for a spot speed data. Okay, clear? What is the aim of collecting spot speed data? We want to know the choice of drivers about the speed. At what speed they would select, what speed they would select in a particular situation. Okay, on a particular spot on the road or a segment on the road, at what speed a driver would like to go. Okay. Now, when is this possible? If you have a queue, if you have a queue of vehicles in front of you, can you select your own speed? Maybe for 1 second until you go and crash with the other. Okay. That is just 1 second of happiness, and that's it. Okay. So we need conditions in which drivers can choose the speed. Otherwise, this study is useless. Because we want to know the speed of the drivers according to their choice. So we should collect the data when the drivers actually have the choice. Okay. So those conditions are called as free flow conditions. Okay. So we discussed the free flow case in the first chapter as well. Free flow speed. Okay. So free flow condition means what? That you are so far away from the other vehicles that you are basically not considering them when you select your speed. You just look at the road, okay, it's a big road or a small road, so I will go at that speed. but I'm going on the gradient or down the gradient, so my speed should be this much for my own safety. Clear? Okay. Now, what is an ideal free flow condition? What is an ideal free flow condition? What do you consider as ideal for free flow conditions? You want to do a speed study in a free flow condition. The ideal is what? Empty road, and the speed of what? What should I take the speed of? I'm doing a speed study, right? Empty road means what? No vehicle. One car, ideal, right? Huh? You go to the road for a speed study, you find one car on the road. You can take one value, right? Happy? Done? Is it enough? Keep on looking for that, they are came to me. We will do the speed study by ourselves. Just keep on driving over that. Okay, if you find one car or no car on the road, then the important question is what? What are you doing at that time? You should also go home, right? Have parents and other things, right? Now, go home, sleep, come early in the class next day. Okay, clear? Okay. So yes, free flow conditions are ideal, but the data collection in those conditions is basically not possible. Okay. So again, we have a range. Okay. So if the flow goes up to these ranges, it's still considered free flow. Okay, still considered free flow. What are these ranges? If it is 500 or less, no problem on any highway. Okay. If the flow is 500 per hour or less, no problem on any highway, street, whatever. Okay. On major highways, big highways, okay, like the one which we have in front of the university. You go out of the university, that's a big highway, right? 3 lanes and shoulders and 100 km per hour speed. And you all know we don't go at 100, right? We go more, right? Agree? So on these highways, even up to 1000 is okay. Okay? Clear? So we want to do a spot speed study. Our aim is to know the choice of the driver. The ideal situation is you have a speed radar and the road is completely empty, and then you are taking the data. Okay? But to have these ideal conditions, you may not have them actually. So instead of a radar, you can use a stopwatch and keep the distance under 1000 feet. Instead of fully free flow conditions, you can have a flow in these ranges and still it is considered fine. Okay, clear? Okay, so we have ideal conditions and we have the allowable conditions for taking the traffic flow data. Okay, so where do we use a spot speed data? Again, remind me, what is the aim of doing spot speed study? To know what? To know what? What are we trying to find out? Huh? Free flow speed. Speed of who? Who is deciding the free flow speed? Who is deciding the free flow speed? The driver. Okay, so we want to know the choice of the driver. Okay, where do we use this value? The choice of the driver, where do we use it? So speed limits. When we set the speed limits, I mentioned it in the last chapter as well. It should be according to the expectation of the driver. Okay. So you go to a big highway, good design, no signals, 3 lanes, 4 lanes, shoulders, median, everything is there, marking is there. Okay, and you put a speed limit of 50 kilometers per hour. What is it? A waste of money, right? And then you go to a small street and put a speed limit of 100. What are you trying to do? Kill people. Right? It does not go according to the expectation of the driver in that situation. So the speed limit should follow the expectation of the driver. This is the first thing here. Second is related to design. Second and third points are related to design. When you are designing, for which case do you design? Worst case or the best case? Worst case. In terms of the speed, which one is the worst case? High speed or low speed? High speed. Why it is the worst? Is it not good for the driver going at high speed?
Biggest accident.
Because of the safety. Okay, you design for safety, right? Your main objective is to ensure the safety. Okay, so in terms of safety, high speed is the worst. Okay, and we know high speed will be attained in free flow conditions according to the driver. Okay, so whenever you are designing the radius of the highway, the gradient of the highway, vertical curve, okay, you are designing a signal, a roundabout. Okay, so all these things are designed according to the worst case scenario, which is the speed in free flow conditions. Yeah, and which you will get from the spot speed studies. Okay, and signal timings are again according to the some of the signal timings are according to the speed of the drivers. Okay, something which we already mentioned. Okay, that speed is related to what? Safety. Right. So if you have a problem which has a if you have a location which has safety issues, and you are going to investigate what are the reasons of having many accidents at this location, then your investigation must include speed studies because of the link. Okay, because of the close link between the speed and safety. Okay, so if you find a problem with traffic accidents, then speed study should be part of your analysis, should be part of your investigation. Clear? So in all these cases, we do or we can do the spot speed studies. Before we go on to the data, some of the things which we have to consider, okay, or some of the things which you should know. First thing is the most important item which you will collect for, which you will do for your term project as well. By the way, in the second task of your term project, you are doing a spot speed study. So keep all these points in mind when you have to do it. What are the conditions on it? So once you collect the data, then you have to calculate the average or the mean of your data. Okay, all of you know about average and mean, right? So we are talking about mean of speed, right? Mean of speed. In the first chapter, we discussed there are two types of mean speeds.
Space mean speed, time.
Space mean speed and time mean speed. Now we are talking about mean of which speed here?
Space mean speed.
Time mean speed. Yes. Now what did we call this? Spot speed, right? So a speed over a spot. So now tell me. Time means speed or space mean?
Yeah.
Speed over a spot.
Yeah.
Time. Okay, there is no spacing. There is no spacing. Okay, so it's when you take spot speed data and take its mean, it is called time mean speed. Mean of spot speed is time mean speed. Clear? And we know that how to take it or what does it mean. Then we have standard deviation. Standard deviation tells you how much variation is there in the data. Okay, how big is the data? Okay, how much? What do you call it? How much is the sparsity in the data? Okay, how far is the data from its values? Okay, so just in terms of understanding, think about standard deviation as the difference between the values and the mean. The difference between the values and the mean. Okay, so if the mean is 50, okay, and the value is 51, so the variation is small. The mean is 50 and the value is 100, that means the variation is large. Clear? Okay, so when standard deviation increases, that means the variation in the data has increased. Clear? Okay, we don't calculate it as a difference. Okay, there's an equation for that. Okay, so I will show you the equation later on, but just think about it that standard deviation means the variation from the mean to the data, variation between the mean and the data. Clear? And then we have the 85th percentile speed, which is important for design. Okay, for traffic flow analysis, we can use average or mean speed. For traffic flow analysis, we use average or mean. But for design, we don't use mean. Why not? Yes. No. Why don't we use mean for design? Huh? What's the problem with mean? If you take the mean, what will happen? Yes, you want the highest value. Yes.
It's not the worst case.
It's not the worst case. Okay. So taking mean means that you are taking a middle value. So middle means that you are ignoring half of the data, which is not good. Mean is in the middle, so you took half of the data up to the mean, and more than the mean, ignore, which is not good. Okay. So what do we do then? We take 85th percentile of the data. 85th percentile means what? It is the 85th highest value in the data. 85th highest value in the data. If we have 100 values, you arrange the data in ascending order, lowest at the bottom, highest at the top. So in this order, the 85th value will be 85th percentile. Okay, clear? Okay. So instead of taking mean, the value near the middle, we take the value which is the 85th percentile, which is obviously then you have crossed the middle, right? You have crossed the middle now. Okay. So how much data you are covering now? 85% data is covered. Okay. And how much data is not covered? 15%. Okay. Which is allowed? Which is allowed? Okay. You have too many people in the world. Some of them will die if you have more space. Okay. I tell these things so that you don't ask me. Okay, I didn't write the book. Okay, so the authors, they wanted 15% of the people to die. No problem. Okay, what is the median then? The mid value. Okay, median is the middle value. So in terms of percentile,
15 percentile. 15 percentile.
15,
50.
50th percentile. Okay, so this is the 50th percentile, right? So if you arrange the data, it will be exactly in the middle. So 50% data up, 50% data is low. Now the mean and median can be different because mean is calculated. Okay, so you put all the values, put them together, divide by number. Okay, so you may get the value which is exactly in the middle, equal to the middle, but it can be more or less because you are adding and dividing. Okay, but median is always in the middle. Median is always in the middle. For example, if you have three values, 1, 3 and 5, what is the median? 3. What is the mean? 3, right? Now it's 3. 1, 3, 7. What is the median? 3. What is the mean? 11 or 3, which is very difficult. It will take time to do, right? But we know it's not 3, right? We know it's not 3. So you can see here the mean is affected by the extreme values. If we change the extreme values and keep the rest of the values same, the mean will change. But the median will not change. Okay? So this is what happens in a big data set, that the values in the middle, they are normal values. Okay? And then we have one which is very high or very low. So if you remember in the last chapter I told you, we avoid these values. So that the mean and median are close to each other. Okay, this is the reason. Otherwise it will disturb your mean. Okay, then we have pace. Okay, pace is not a value, it's a range. Okay, it's a range of speed, and the difference in that range is always 10 miles per hour. So if the first value is 10, the last value is 20. If the first value is 15, the last value is 20. 25. Okay. Like if you are so good with maths, you should have the calculator in front of you, always. Okay? So it's a range. Okay? So what do we do if you have the speed data? Divide this data into 10 miles per hour ranges. Okay? One of these range is space. Which one? The one which has the highest value in its range. Highest number of vehicles in that range. Okay? For example, I have a range between 10 to 20. How many people are traveling between or driving between 10 to 20? Let's say 5. Okay? Then I have the next range between 15 to 25. How many people are driving between 15 and 25? 10. So which one is higher? This one is higher, right? The last one was 5 drivers, and this one has 10 drivers. So this one is higher, right? So this one can be the pace. Okay? If there is no other range with more values, then this one will become the pace. Clear?
Yes.
Okay. Any questions? Yes.
We take each 5 once per hour.
No. It's not like that. There is a method, but I am just trying to explain. What does it mean? Okay? You got what the pace means. We'll go through how to calculate them. The standard deviation and the pace and 85th percentile. We will go through it with the data. But did you get the concept? The concept is, in your speed data, there is a 10 mile per hour range which has more drivers in itself than any other range. That is pace. Clear? Clear? Okay. So we know we can collect data using manual technique or semi-automated or automated. Okay. If you are using a stopwatch, then it is manual. If you are using a radar where you have to press the button every time there is a car, it is manual. You have to press the button, it's manual. Okay. If you have a radar, when the car crosses, it takes the data by itself, it's semi-automated. If you put a detector which can record and transmit the data at the same time, and you don't take to take it with you, it is fully automated. Okay, so it can be any of these things. So this is one of the fully automated method that you put a loop detector. Normally they are put near signals. So you can see it is connected to a cabinet, right? Have you seen these cabinets? In the rush hours you will see police officers there, right? They are doing some up and down and so on. Okay. So never be on their backside. You don't look there. Okay. So just anyways. So we call it a loop detector. It's a loop detector. Okay. So it can measure speed as well. It's very common in Bahrain and in other countries as well. Okay. Once you have the speed data, we need to divide this data into groups. Okay. Once you have collected the speed data, we need to divide this data into groups of speeds. And for each group, we will find out how many observations we have seen. For example, you have data which has minimum value of 20 and maximum value of 50. Now from 20 to 50 you will make groups. Let's say you are going to make 6 groups. Okay. So the first group from 20 to 25, next one 25 to 30, then 30 to 35. Get my point? Okay. Then you will see how many values did I observe in each group. Okay. So how many values between 20 and 25? These values are called as frequencies. Okay. So the speed data has to be divided into groups, and then you have to find out the frequency for each group. Clear? Okay. So it will look something like this. You can see the first 2 columns are showing the speed data. Okay. Can you tell me the size of each group? 2. 30, 32, 32, 34, 34, 36. Okay, so the speed data is divided into I don't know how many groups, but with the size of 2. Okay, the size of all groups should be same. You cannot do 30 to 35 and then 35 to 37. You cannot do this. All groups should have the same size. In front of the group, then you see the number of values for that group. So how many values from 30 to 32? 0. How many values from 32 to 34? 5. Got it? Clear?
That's the frequency.
That's the frequency. So the first two columns are the speed groups and the last column is the frequency. Okay? So between 32 and 34, they observed 5 drivers. We don't know their exact speed, but we know they were in this range. Got it? Clear? Can you see these lines? They could be helpful to you now or in the later stage because you have to do some counting for your term projects. So these are called as telemarks. Okay, so when you are counting anything in the field, the cars are passing obviously very fast, so you have to be very fast as well. So if you start writing numbers, then it will take more time. Okay, and it will keep on getting longer and longer. So if you have 10 vehicles, now you have to start writing 2 digits, right? 10, 11, 12. And if you reach up to 100, you start writing 3 digits. So you will keep on getting slower and slower. Okay, so instead of that, what do? We just put lines. Vertical lines or inclined lines. Okay, so if you saw four vehicles, you counted 4 vehicles, there will be 4 lines. Okay, if there's a 5th vehicle, I'll not put a 5th line, I'll put an inclined line. So every 5th vehicle is a inclined line. Okay, so whenever I see an inclined line, it means how many vehicles? 5. So this is how many? 5. And this is 5 plus 2, 7. Okay, so it makes it easier in the end as well to count. Clear? Okay, one more method which I saw from a faculty member actually. 1, 2, 3, 4 and 5. He was doing it in his office. Okay, on a paper. There were no cars. Okay, so keep this in mind. It will take more time to do like this than this. Okay, but anyway, there's another method. Clear up till now? Any problems? Okay. Yeah. How do we decide about the size of the group? Here it is 2. Okay. According to the recommendation of the book, 2 is considered as the best size. According to their judgment, their experience, their research, 2 is the best size. Okay. Then again, according to them, we should not go more than 5, and all these values are in miles per hour. So according to them, 2 miles per hour is the best size, and 5 miles per hour is absolute maximum. Your group size should not be more than 5. Clear? Then what are the other things you can consider? So you can, if they are saying 2, you can have a group size of 1 as well, no problem. You can have a group size of 3 as well, no problem. Okay, but you have to keep one thing in mind. If you make it too small, if the group is too small, for example, I make the group size 0.5. Okay, so there will be many groups which may not have any value. So you have a group between 30 and 30.5, then 30.5 to 31, 31.5 to 31 to 31.5, so on. Okay, so they may be very, they can be a number of groups with 0 values, which is not good. If you can make bigger groups, then you will have more groups with values. Okay, so don't make it too small that half of the groups are having 0, 0, 0. It's not good. Okay, but don't make it too big as well, so that the entire data is only 2 groups. Okay, the minimum number is 5. You should have at least 5 groups with values. At least 5 groups with values. If you have, for example, you made 6 groups. or 7 groups, one or two of them have 0 values, it is allowed, no problem. Okay, some groups can have 0 values, no problem, but there should not be too many. Okay, so select the group size according to the data you have, so that you have at least 5 groups with values, with numbers more than 0. Got it? Clear? This is the data, so you can see the groups in the first 2 columns and the middle of the group in the 3rd column. So each group has a lower value, an upper value and a middle value. Okay, who decided these values? Huh? Who decided these values? The book. Very good. It is our book, right? It is not the book. Right?
Can be from the book.
Huh?
Can be from the book.
No, you don't know the meaning of the book. The book is there. The 7 values, right? If it comes down there, we cannot change it, right? We cannot change it. Can you change these?
Yes.
Yes. Okay. So who will decide?
Zero.
The observer. Okay. The traffic engineer, the consultant who is collecting the data. Who will that they will decide? I told you, right? You have to look at the data and decide the size of the group and the minimum and the maximum. Okay. That can be in the copy as well. No problem. Clear? Okay. So these 3 columns are decided by the observer. Okay. The minimum, the maximum, the size. So these are decided. Then we have the observations in each group. Okay. So the first group has how many observations? 0. So they did not observe any driver who was between 30 and 32. The next one has 5 observations. They saw 5 drivers who are between 32 and 34. Clear? Okay. Moving to the next column, which is percentage frequency. Percentage frequency. So you calculate the percentage of values in each group. Percentage of values in each group. Number of values in each group. Okay. So you will take the value of each group, divide by total number of values. Total of the number of values. Okay. The most common mistake is sometimes people take value from here and then do the summation of this one. No, this not summation of speed. This is value upon number of values. Okay, not number of speeds or number of groups. Sometimes people count how many groups I have. 10 groups divided by 10. Everything divided by 10. Okay. Take the value, divide by total number of values. Clear? Okay. So the first value is 0, 0%. The next value is 1.36. So 5 is 1.36% of 360. Clear?
Yes.
Clear? Okay. Next one, cumulative percentage frequency. So how do we cumulate? We add. Okay. So the first value is as it is. Second is addition of first 2. Third is addition of first 3, and so on. Clear? And the end you will reach for how much? 100. Okay. So whatever messing up you are doing, you will not get 100. Okay. That means you made a mistake. You. Okay. If it happens in the exam, that means you made a mistake. Be prepared for a 0. So when you get it, it will feel less bad. Okay. When your percentage goes more than 100, then you deserve it. Okay. Then we have 2 other columns. The first one is n into s. What is n? Number of values in the group. What is s? The middle speed of the group. Okay. So how do I get the first value? First value is 0, obviously. 0 into anything. The second value, 165, is 5 into 33. Okay. Next one, 175, which is 5 into 35. Got it? Clear? Okay. Next one is n into s square. So instead of doing n into s, I am doing n into s square. So 0 into 31 square, 5 into 33 square, again 5 into 35 square. Clear?
Yes.
Okay. This one will be 2 into 65 square. Clear? Okay. and the summations of these values are given here, and obviously summation of this should be 100. Okay, based upon the values in the table, we calculate, we plot these two graphs. This one is called percentage frequency graph, percentage frequency distribution graph, percentage frequency distribution graph. Okay, so on the y-axis percentage frequency, on the x-axis middle speed. On the y-axis which column? Which is which column? Column number what? 5. This one. Okay. And on the x-axis which column? 3. Column number 3 middle speed. Clear? This is percentage frequency graph, percentage frequency distribution graph. Then we have another one which is cumulative percentage frequency graph. Cumulative percentage frequency distribution graph. Okay. So on the y-axis, cumulative percentage frequency distribution. The x-axis has the upper limit of the speed growth, not the middle, upper. Okay. So on the x-axis, tell me on the y-axis which column? Number 6, this one. And on the y-axis which column? Sorry, on the x-axis which column? 2. Okay. The upper limit. Clear? Okay. So you use the table to get the x and y values, and you plot the points. Can you see the points? Can you see the points? Both the graphs show the points. Okay. Then we draw the curves. Okay. Are the curves joining the points? No. Okay. The curve doesn't join all the points. Okay. Our aim is to plot the best fit line or the best fit curve, also called as the trend line. Okay, so when we plot the data, we are not looking to join all the points. We are looking to plot a best fit line, a best fit curve, which is also called a trend line. If you use any software, then if you use any software for plotting, okay, Excel, MATLAB, it will give you the option to make the best fit line as well. Okay. In the good old days, we used to do it by hand, wherever the hand goes. You close the eyes and do this. Okay. But what's the point here? If you look at the first 2 points on the top graph, okay, first 3 points, what will happen? The first point, now try to join the second and the third. You can see the graph will start going up and down. Okay, so it's not a smooth shape. So the idea of a best fit line or a trend line is to get a smooth shape which is close to the data. Get a smooth shape line or a smooth shape curve which is close to the data. Close it. If it is close enough, that's good. Okay, this will do. Okay, so in getting close to the data, if you can join all the points, good. If you can join all the points and get a smooth shape, good. If you have to leave out 2 or 3 points, but you get a smooth shape, good. Okay, clear? Now you look at the first graph. Okay, what is the first value on the graph? On the x-axis, on the y-axis? 0, right? Okay. And what about the last value? 0. Okay. Now you look at the data. Why they are 0? Because the first group has 0 values and the last group also has 0 value, right? So where is the start of my actual data? Tell me. Where the actual data is starting from? The second group, right? Okay, which starts from 32. Okay, and what about the end of the data? 66. Okay, so if I remove this group, 66 to 68, and if I remove that group, 30 to 32, it will not have any effect on my values, right?
Yes.
It will not have any effect on my values, the data. Okay, so why do we have them? We have them to make this trend line or best fit curve to the last extent. Okay, the last to have a good best fit curve or a trend line, okay, it is more appropriate to do it from the axis. Okay, so now you can see with the zeros, I start from the axis and I end at the axis. And even in the second case, I'm starting at the axis and I'm ending at what? 100, because this is the last value. 100 is what? The last value. It's cumulative frequency, it will never go above 100. So again, I am starting and ending at fixed points. Okay, I'm starting and ending at fixed points. Okay, so this is why we had the 0 groups. Okay, clear? Any questions? Keep in mind you have to do the spot speed study for your term project in the second submission. Okay, and you have to calculate the mean. Okay.